Hey everyone, welcome to Let's Create, a series where we take mechanics from popular games and recreate them using blueprints in Unreal Engine 4. Today we'll be creating the gravity gun from Half-Life 2. If you're new to this channel, make sure to check the description below for the Foundation series video. Let's begin. The first thing we're going to do is go onto any internet browser that you have available, and in the description below I've added a link for this tutorial where you can go to kenny.nl, and this website has a bunch of really great assets that we'll be able to use for tutorials and that you can actually use in your games, as a lot of them are public domain. So what we're going to do is hit download on this pack so we can get access to this modern rocket launcher, which we'll use to visually represent the gravity gun. And once you've done that, I'm just going to bring this down here, go to your desktop and open up the weapon assets. So I'm using WinRAR, so whatever you have available, use that. And I want you to go into the models and extract the rocket launcher modern OBJ. And just drag that onto your desktop and close that. And then you can close the weapon pack website. And then in your art folder, which we made a few lessons ago, you can go into, we made this for the jump pads and stuff, I believe. So inside of the art folder, you can drag in the OBJ, import that. Don't worry too much about these warnings. And we can create a new folder, call it rocket launcher. And then we can drag all of these into the rocket launcher folder. The next thing we can do is quickly, because I've already tested this out, I know we want this piece. These two are actually rockets for the gun, so we want to just click on this and rename it Rocket Launcher Mesh. And that will be easier for us to access later. Go back to Content, Blueprints, and inside of here we're going to duplicate our FPS controller and we're going to create another character. This time around, the character we're going to create is Gordon Freeman. And we're going to open Gordon Freeman, go into the viewport, just minimize this for a second, go back to Content, Art, then Rocket Launcher, and we're going to get the Rocket Launcher Mesh and make sure it's a child of the camera by dragging it underneath. We're then going to go back into here, and you'll notice the rocket launcher is really small. I believe this asset was designed with Unity in mind, but that's okay. Because this is a tutorial, the scale won't matter too much. So we can just make this 1200 for all these axis values. And then we just have to rotate it in place. So press E and then go into the rotation and rotate that. And then we can drag it to a place where it might look potentially good, and we can test it by pressing play. So I'm going to have a guess, and hopefully this is correct, having it over here. I'm then going to hit compile and save it. Then in the blueprints, I want to make sure to go to the FPS game mode that we created in the Foundation series. And then on the default pawn class, make sure that you select Gordon Freeman and compile and save. Then you can close that. And then we'll minimize this and hit play. And you'll notice that this rocket launcher asset is here. We can then maybe drag it to the left a little bit more, and if you want you can bring it out, compile, save, and something like that is perfect for now. So what we need to do now is set up all the functionality to pick up and launch objects, and also have the ability to drop them. We're going to first of all create a physics handle, and a physics handle is another component that gets added onto this character, and it allows you to have access to a few events. It allows us to actually pick up and drop objects, because you can grab components and you can release components, which you will learn in a second. The only other thing we need is to create a add component and a scene component. And I have clicked on the rocket launcher mesh before adding the scene component, so it becomes a child. So make sure it's a child of the rocket launcher mesh. And this is going to be the held object location. You're then going to put that in front of the rocket launcher. somewhere like this. And this is the location where the object will be held that you can then launch off. So it's completely up to you how close or far away you put this held object location. Once you've done that, go compile, save it, and now we're going to go to the event graph. Inside of here, we're going to start by setting up the pickup. And we're going to use something new today called custom events. So right-click and type in custom event. We're then going to add custom event, and we'll call this, let me zoom in a bit, we'll call this the pickup object. A custom event is a node, and it's an event that can be called over and over again. In previous tutorials, we may have duplicated large amounts of nodes, but this is actually inefficient. What you can do is you can set up all your functionality for this event, and then what you can do is right-click and call pickup object, and we've essentially created our own node, just like add controller pitch input. So whatever this event does, we can call it again and again, and it's going to make our lives a lot easier in the future. So with our pickup event, we're going to first figure out how we can actually detect an object. And we're not going to use a collision box for this, we're going to use a line trace. So drag that out, create a line trace by channel. So this one over here. And first of all, we need to create a start and end location. Now the thing that makes the most sense for these are to use the first person camera. That way, wherever we're looking, we can shoot a straight line out. So let's go and get the camera. Then we can get the get world location. And this is going to be where our line trace starts. And then what we're going to do is get the get forward vector. And this is so we can shoot the line straight forward, not left, right, back, up and down, but where the player is looking directly in the middle of the crosshair. We can then times this value by an amount. And this amount is going to be how far we want the line to shoot. So how far you want to pick objects up. So we're going to create a new variable down here. We're going to call this the pull distance. I'm going to drag this out, hit compile, and make sure it is a float. Press compile again to change this. And let's say for now we make it something like 400. We could then drag this variable get and put that into there. The next thing we want to do is we want to plus this by this. So that plus vector, then we'll get the location. I'm going to just drag these back a bit, and then this will be the end point. You can also draw the debug just for a duration if you like, just to visually see what's happening. The next thing we're going to do is from out hit, we're going to break the hit result, which will give us access to the hit component and the hit actor. And then from there, we're going to first make sure that we've actually hit something. So branch. And if we have, which will be true, we're going to see if the hit object is simulating physics. There's no point in testing or there's no point in trying to grab an object if it is not first simulating physics. So from the hit component, drag out is simulating physics, which will return a condition. Don't worry about the bone name, that's irrelevant for what we're doing. Drag this out, create another branch, and then drag that into true. The next thing we want to do is, if we know it is simulating physics, so we hit an object, it is simulating physics, let's grab that object. So drag this out, grab component, and we're going to grab component at location with rotation, and this is a function unique to the physics handle. This is a node unique to the physics handle, which is why we are using the physics handle in the first place. This is going to allow us to grab an object, and the object in this case is the hit component, which we can drag into component. We can then double click to make this a lot tidier. And the location of the object, of course, is when we drag this out, get world location, which we get the world location of the object, allowing us to plug it into here. After this, we need one more thing for our pickup system to work, and that's to have a variable so we can see if we are currently holding an object. In that case, it is going to be a boolean, and it is going to be is holding object. We can then drag this out, set this, and set it to true. And now that we've got this entire system set up, we can highlight all of that, press C, go to comment, double click it, and this will be our pick up event, which we can now call whenever we like. The next thing we want to set up is the ability to drop the object, and we need to create another custom event. So right click, custom event, and this will be the drop object. Now this is a very simple one because the physics handle comes with a node called release component, which does exactly what you think it does. It will release the component so it can fall. Once we've released the component, we then need to set is holding object to false because we're no longer holding an object. And once that's done, we can highlight it all, press C, and this is the drop object event. One of the final things for this is to set the object location. So we're picking up an object and we're dropping it, but we need to update every frame the location of the object or none of this will work. In order to do that, we need to create a event tick. So I'm going to go over here, create an event tick, and for this event tick we're going to drag out and call a node called set target location, which is part of the physics handle. And the location is the held object location. So if you see here, we have component held object location. So right click, held object location. We can then get the get world location, and then we can plug this into here. You can then highlight it all, press C, and we can call this the update object location. Okay, so this in real time will allow the object to be updated every frame, so it'll look like you're moving this object around you with your mouse. And these are the events that allow you to do so. The other thing we need is input, because you can't call these events without a form of input. In order to do this, we need to right click, and we're going to just use left mouse button, and we're going to make a branch. And the condition of this branch is if we are not holding an object, so is holding object. If this is false, we're going to call that custom event we made called pickup object. We can then comment this, and this can be the pick up and launch input, because later we're going to add functionality to launch the object. But for now, I want to illustrate what we've accomplished. The only other thing is we have also made the ability to drop an object. So right click, right mouse input, right mouse button. We're going to create another branch, and we're going to do the exact same thing where we see if we're holding an object. If we are holding an object, well, let's call that event drop object. And then these bunch of nodes, we can comment them by pressing C again, drop object input. Okay, these are all the things we need set up in order to pick up and drop an object. These hold all the functionality within the events, these inputs call the events, and this updates the location in real time. So let's go back into the game, press play, and walk up to an object. If you left click, you'll pick up an object. If you right click, you can drop it. Pick up and drop. And you'll see you are also creating these line traces. So pick up, drop object, with right click, pick up, drop object, whoops. And we have a distance set up, so you can see from a distance, from about here, you can pick up that object, move it around, and right click to let go. So we have everything required. The only thing to do next is to launch the object. So I'm going to press F11 to get out of full screen and go back into Gordon Freeman. And in here, we're going to launch our object. And this one's quite simple. So we're going to drag this down and we're going to use part of this. So we're going to create another custom event. So custom event, this one will be launch object. Then we're going to branch out, and we only want to launch if we are holding an object, of course. So we get is holding object. And then first of all, we're going to go, if this is true, let's call that event we made drop object. So we're going to drop it. The reason why we're going to drop it is because if we add any force or impulse whilst holding it, it won't really fly away because it's trying to get back to our origin. It's trying to get back to the held object location. But if we drop it and then add impulse, it can fly away freely and it is not constrained. So we're going to drop the object, and then what we're going to do is from our hit component, drag this down here and add impulse. And we'll just drag this over here to keep it a bit neater. And over here, we're going to go from drop object to add impulse. And the direction for this impulse will be from the first person, the camera. So get the camera, get the forward vector of the camera, and then we're going to times this by a float. And the amount you times it by is how much force that will be added to the object that you're launching. So for this, drag that into impulse. I'm going to enable velocity change. And the reason why is because if we don't, you're going to have to put a ridiculous amount like 40,000. So hit velocity change. So it ignores the mass for now. And we're just going to add a amount into here like 2,400. And if you like, you can create a variable for this. I'm then going to drag over this, hit C, call this the launch object event. And I might drag this down a little bit more. And over here under pickup and launch input that we made earlier, if you press the left mouse button and you're holding an object, well, let's launch, whoops, move my mouse, let's launch the object. Hit compile and save. I'm then going to add in a few more of these physics blocks. So I'll add in some over here, a bit closer to the ground. Duplicate them around, and let's have some fun with this. So hit play, full screen with F11. I'm going to go over here. So if I left click to pick it up and left click, it flies and launches, and I have dropped the object. So I have my gravity gun launch, and I can propel objects. I can also left click and right click to let go if I wanted to build crates like in Half-Life. So I could jump up here, whoops, grab this, right click, whoops, let's try that again. I think my mass, I believe I changed the mass on my character when I created that super hot, or I created I believe I changed the mass on these objects actually. Let me have a quick look. So, oh, that's quite light. Let's make this 300 for all of these. Let's try that again. So pick up, put that down. Ah, there we go. Okay, yeah, I had the mass way too low. So if I want, I could increase my gravity gun so I can pick up objects from a greater distance. So see here, whoops, I launched that. I was meant to right click. But yeah, as you can see, it's working really well. So I'm gonna go back into my blueprint really quickly, and I'm going to go to my pull distance and make this something like 800 just for this video. Control P, F11, and let's go over here. Now I can pick it up from a greater distance. So let's see what we can do. So left click, get up here, right click, jump, jump again, left click. I don't know if this is gonna work. Actually, I can jump up here, right click. Oh no, it all fell over. Awesome. Anyway, that's it. This is the gravity gun for Half-Life 2. So you've created all this great functionality using physics handles. So today I hope you learned quite a bit about physics handles and custom events, something we have never really covered before, which we will be using from this point on. Thanks for watching, everyone. If you'd like to see a part 2 next week, where we would add in particle systems and sound effects, let me know in the comment section. If you enjoy this content, consider supporting me on Patreon. It all helps me invest more time into my channel and develop higher quality videos. Expect to see a mini spotlight video of the Mirror Game Jam in the next few days, and I'll see you all in the next video.